Hello, welcome to Topper Machine. I'm Josh Topper. So what I got next to me are some conveyor rollers, and I build a lot of these for a lot of different industries in my area. It's one of the things we're really good at here. And these particular rollers came out of a veneer mill. They're inside the drying oven. They run on a carbon bushing instead of a bearing because of the heat. And over time that bushing wears out. They get down into the cast iron holder, and then you got steel on cast iron. They just chew themselves up. These ones have one end that's bad. So what we're going to do is we're going to throw them up in the saw. We're going to cut one end off that's bad, and we'll make a new end for it, and then weld them back in and put them back into service. So let's get sawing. So these two are ones I built before, and these are somebody else's. They just had a little cap welded on the end with the stub shaft in it, and I build them a little different. I have a piece that actually is turned down to the size of the ID of the tube, very close to, with a couple thou clearance, with the stub shaft welded in, and I drive it in, and that keeps everything true. Well, now I've got this piece here I got to get out. So I'm going to build just a quick and dirty slide hammer. And I'll tack weld a nut on here, and then we'll just use a slide hammer and pop that thing right out of there. So when I said quick and dirty slide hammer, that's what I meant. So all I did was weld the nut on there, a sacrificial nut, thread my threaded rod with my little slide hammer on there into it and just pop it right out. It went really nice. So I got one more of these to do, and then we can get on to making the replacement ends. Okay, so I got all the shafts cut to length. I got my inserts cut. These just get bored to the size of the shaft, and then it gets welded together, and then I chuck it up afterwards. Once everything is done, chuck it up again, turn it down to the finished side of the tube, and then we slide it in. So let's get these up in the lathe and start making our stub shafts. So we turned out 2 different size shafts here, 2 different ends. We needed 1 of the long one and 3 of the short ones. And they're turned out, they came out nice. Tomorrow we will take our blanks here and we'll just rough out an 1.25 inch hole. So we'll just run a drill through it. And then I put those stub shafts in at a measured depth, weld them in, and then I chuck up on the shaft and I turn the outside diameter of the puck here to just fit in that tube, and then we weld it in the tube. So tomorrow morning we'll get started on that. So I'll see you in the morning. Well, welcome back to the shop. So next morning, had a pretty good night's sleep. And what we're going to do today is take our 4-inch blocks here that we need to chuck them up, drill a hole through that our spindle will fit into. Put them together, weld that up, and then we'll bring it back over, chuck it up, and turn the outside of this puck down to whatever we need to fit tightly into the roller tube. And then that gets welded in. This is what is basically our pilot, which will keep everything straight. So let's get drilling. Okay, we're back here in the weld shop. I already set the depths on my stub shafts in the pucks. They're just tack welded in. We're going to throw it up in the weld positioner next. This is a Profax weld positioner, and I really like this thing. It's been very handy here in the shop. So let's get welding. All right, we got them all welded up. They're all cooled off finally. And we'll chuck this up and turn this outside diameter of the puck here to a very tight fit. You know, we're going to try for a couple thou. We're going to wind up tapping it in, which will help keep this absolutely straight. So let's get turning. All right, this one came out nice. The next two are a little bit smaller. The roller tube was different sizes, so the next ones we'll start at our start point where we're at and then turn it down and measure it and get our final size and set the DRO, and the second one will go pretty good. Now, a very important thing to remember when doing something like this where you're chucking up on a smaller shaft, turning a bigger piece, is don't take too big of a cut, because you've got more force here cutting than you have here holding, so it will want to spin. So you just got to be careful of that. All right, so we're back here in the weld shop again, and this is going to be a very tight fit, but that's what we want. We want it to go in tight so that it goes in straight. So I'm going to start tapping it in and we'll see how it goes. That's going in very nice. Before I get carried away though, I'm gonna measure my overall length and then make sure I got it the right length before I go too far and have to try to get it back out. All right, so I got it in the distance I need it to be. Let's see how it looks. Beautiful. Now this isn't the high-speed application. It doesn't have to be absolutely perfect. I've gotten these before that were way crooked, and now that I'm doing them, they're actually going way better. So we're just going to keep doing them this way. I got a different method for different rollers, but these particular ones, this works really well. So let's go ahead and weld this in, and we're done. Well, this roller's done and ready to go back into service. Just a little polish there on the weld just to make sure there's no sharp spots with the flap wheel, and this one's ready to go back out and do its job. And as you can see, I've got a whole pile of other ones here to rebuild, and these are ones here, these small ones are ones I just built. They're brand new to replace some really damaged ones. The 25N Monarch is still for sale as of right now, and I'd really like to find it a good home fairly quickly because I do have a new machine coming in and it's taking up the valuable space. I'm going to be very crowded in here if I wind up keeping it in the shop. So finding a new home is really, really important. I will not put it outside. A lot of you suggested put it outside. No, never. I won't move a machine outside. I would never buy a machine that sat outside, and I don't expect anybody else to either. It's just too hard on the equipment. I made that mistake one time. And a lot of you have suggested Adam Booth. Adam and I have actually been talking about this, and he's actually promoting it on Instagram and helping me boost this to try to get this lathe to the right person, try to find the right buyer for it, and I really appreciate all the help, Adam. I hope we can find a good home for it really quickly. And many of you saw my video on the machining the big part for the Mark Twain Zephyr. We did it here on the horizontal boring mill with this big fly cutter that I made, and there was a lot of comments on how it was hard on the machine, why didn't you use a face mill, things like that. Well, really this machine can take the beating. It's well built, it can handle this very well. I don't like doing it though, I really don't. I just do it when I absolutely have to. Well, this just came today. This is a 6 Morse taper face mill adapter with a 2.5-inch pilot, so this will take a big face mill. I'm looking for a 10, 12-inch face mill that doesn't use obsolete inserts. Everything I have here is kind of an obsolete insert and hard to find. So I'm looking for something more common, more standard, easy to find, but in a 10 or 12-inch face mill. So if anybody knows of any, please let me know and I'll pick it up. So until next time, get out in your shop and get it done right the first time.